Question 13. Without using a calculator, solve 9 times, and then all in parentheses, I have 1 plus 9 to the x minus 1 equals 10 times 3 to the x. Okay, so I'm going to distribute the 9 to each term in the parentheses because I don't like that times out front. That looks crazy. All right, so I got 9 plus 9 to the first times 9 to the x minus 1 is equal to 10 times 3 to the x. Okay, so now I've got 9 plus 9, and then when I combine these two, right, I have x minus 1 plus 1 equals 10 times 3 to the x. So these end up canceling actually, and then I have 9 plus 9 to the x equals 10 times 3 to the x. All right, so, I see it. Okay, so 9 to the x can be rewritten as 3 squared, all raised to the x power, plus 9 equals 10 times 3 to the x. Okay, now I have a 3 to the x as my base. I'm like, all right, this guy's going to end up being quadratic. So I'm going to move this over. He is a sneaky quadratic. I have 3 to the x. I'm going to rewrite him squared. Wait, why did I move him over? I don't want to move him over. I want to keep the 3 thing positive. I'm going to move him over. Yeah, there we go. Okay, so now I've got 3 to the x. I'm rewriting him as a piece squared, minus 10 times 3 to the x plus 9 equals 0. So then now I'm going to let u equal 3 to the x. And I now have u squared minus 10u plus 9 equals 0. So then I've got u minus 9, u minus 1, u equals 9, u equals 1. Okay. These are both in exponentials, so they're not in logs, so I don't need to end up testing my solutions at the end. I just have to find out what x equals, so that's fun. So I have 9 equals 3 to the x and 1 equals 3 to the x. So if I log base 3 both sides, these cancel, and I end up with log base 3 of 3 squared equals x. These cancel, I get x equals 2. And then here I've got log base 3 of 1. Come on. Log base 3 of 1 equals log base 3 of 3 to the x. These cancel. Whenever there's a 1 in the argument, it's 0. So x equals 2 and x equals 0.